Welcome to This Explainer. Today, we're going to demystify some of that dense academic jargon and go on a bit of a journey through the incredibly diverse toolkit of research. Seriously, it's like a metaphorical road trip to explore all the different ways we humans discover knowledge. Let's get right into it. So let's kick things off with what seems like a super simple question. Are all research studies exactly the same? I mean, it's really easy to picture research as just one monolithic thing, right? You probably imagine some scientist in a crisp white lab coat pouring bubbling liquids into a glass flask. Well, we need to shatter that illusion right now. Research is absolutely not a one-size-fits-all activity. Think about it like vehicles. You have different types of cars and trucks for totally different roads and jobs. In the exact same way, there are entirely different types of research designed to solve completely different types of problems. Let's put this into perspective. Imagine 10 different people visiting a hospital on the exact same day. You've got a doctor actively treating patients, a scientist studying cancer cells in the lab, an engineer developing a high-tech medical robot, a psychologist looking into patient stress, and maybe a nutritionist tracking everyday eating habits. Now, every single one of these professionals is technically doing research, but are their methods and purposes the same? No way. Not even close. The kind of research they do changes completely depending on what they're ultimately trying to achieve. And that actually brings us to the first massive divide in the research world. On one side, we have basic research. Picture a curious little kid just asking endless questions like, why is the sky blue, or why do birds fly? They aren't trying to invent a new product, they're just deeply, naturally curious. Then on the flip side, we have applied research. This is way more like an adult whose roof just sprang a massive leak in the middle of a thunderstorm. You know, that adult isn't going to sit around analyzing the chemical makeup of the rainwater. No, they need an immediate, practical solution to fix that roof right then and there. Let's zoom in on that first one for a second. Basic research, which you might also hear called fundamental or pure research, is really all about gathering knowledge just for the sake of knowledge. The main question it asks is simply, why does this happen? So, for example, scientists might study exactly how the human brain stores memories, or how insulin regulates blood sugar. They aren't rushing to manufacture a new pill or build a medical device right this second. Their fundamental goal is just to expand humanity's existing stock of knowledge. They just want to understand how nature works. But then, in stark contrast, we have applied research. Now, this approach is all about finding a solution for a very immediate, pressing problem facing a society or a business. So instead of just asking why, applied research steps up and asks, how can we solve this? Think about developing an AI system that scans patient health records to actually predict diabetes. The goal here isn't just to philosophically understand the disease. The goal is to give doctors a concrete working tool to detect it earlier. It's highly, highly practical. So, you might be wondering, how do we bridge the gap between that pure discovery and the practical application? Well, that's exactly where translational research steps in. Imagine a nutritionist who creates this perfectly healthy, mathematically balanced recipe in a sterile laboratory. Okay, great, but serving that to everyday restaurant customers isn't quite that simple, is it? A chef actually needs to step in, modify the recipe, test it out, improve the taste, and then finally serve it up. This entire journey, moving from the laboratory bench to the hospital bedside, or basically from the lab to everyday life, is what we call translational research. It's literally translating basic discoveries into real-world applications. Okay, so how does this all build into the actual investigative pathways a researcher can take? Let's start with exploratory research. Imagine wandering into a dense, overgrown forest that you've never, ever visited before. There are no maps, no signboards, zero directions. What do? Well, you walk carefully, you observe your surroundings, and you take notes. This is exactly what researchers do when they encounter a brand new problem they know very little about. Say researchers notice a sudden, sharp increase in college student stress. They aren't going to just jump to wild conclusions. They'll explore potential reasons. Maybe it's academic pressure, maybe social media, or sleep habits. They do this just to develop a working hypothesis, not to lock down a final answer right away. Once we actually know what to look for, we might move on to descriptive research. I love thinking of this approach like an objective photographer. Your job as a researcher here isn't to intervene or to change the scene at all. It's literally just to capture the state of affairs exactly as it appears in that moment. In the social sciences, you'll often hear this called ex post facto research. It basically answers the question, what exists? For instance, if you send out a survey to 5,000 students to measure their average study hours, their internet usage, and their sleep patterns, but you don't actually try to alter their habits, that is you conducting descriptive research. But what if you really want to know why a specific issue is happening? Enter diagnostic research. Imagine you're driving. Your car suddenly breaks down and you get it towed to a mechanic. That mechanic doesn't just start randomly replacing every single part under the hood, right? They run specific tests to identify the exact root cause. Is it a dead battery, a fuel problem, total engine failure? Diagnostic research works exactly the same way. It asks, why is this problem occurring? A really great example would be investigating the specific underlying causes behind rising obesity rates among teenagers by carefully analyzing things like diet, exercise, and screen time. And that naturally leads us to the final step in our investigative pathway: hypothesis testing research. Picture a tense courtroom. A lawyer stands up and makes this bold claim: the accused committed the crime. Now, does the judge just nod and agree immediately? Of course not. Evidence has to be systematically presented and rigorously analyzed to either confirm or reject that claim. So let's say I make the claim that regular exercise reduces the risk of diabetes. Is that true? Well, researchers have to go out, collect, and analyze controlled data to see if that assumption actually holds up in reality. Okay, now that we've looked at the pathways of research, let's shift our lens a bit and talk about the actual data we use. Imagine two people trying to understand a cricket match. The first person watches in-depth interviews with the players, asking how the captain felt under pressure or what underlying strategy the team was using. The second person, they ignore the interviews entirely and look strictly at the numbers, the runs, the strike rates, the batting averages. That first person is doing qualitative research, focusing deeply on human experience. The second person is doing quantitative research, focusing strictly on hard, numerical statistics. Looking at their formal definitions, the crucial difference really becomes clear. Qualitative research investigates the underlying motives, desires, and experiences of people. It often uses things like in-depth interviews or word association tests to figure out exactly why people feel a certain way, which is absolutely vital in the behavioral sciences. Quantitative research, on the other hand, is entirely based on the measurement of quantity or amount. It applies to phenomena that can be expressed in rigorous numerical terms. And keep in mind, neither of these is better than the other. Both measuring facts and exploring human experiences are equally vital tools in any researcher's kit. All right, we have covered a lot of ground today. So let's do a quick interactive quiz to test things out. Consider this real-world scenario. A teacher notices their students are getting a bit bored, so they introduce case studies, quizzes, and cool animations into the lessons. After the semester ends, the teacher compares student performance to see if it actually improved. Think about the core purpose here. What type of research is this? Take a second to lock in your answer. Got it? And the answer is educational research. You see, the specific goal of this study wasn't just to gather data for knowledge's sake, but it was done directly for the improvement of teaching and learning in a real-world classroom environment. If you got that right, fantastic job. You're really grasping how the ultimate purpose defines the research type. As we wrap up this explainer, I want to leave you with this beautifully simple thought. Think of research like a giant, never-ending relay race. One scientist uncovers a basic, fundamental fact and takes the baton. They hand it off to an engineer who applies it to a specific problem. Then they hand it to a doctor who translates it directly to patient care. It really is an unending conversation. Every single generation takes the knowledge of the past, improves upon it, and contributes something entirely new for the future. And that unending conversation is exactly what you are preparing to join. We've explored everything from the curious child asking why, to the mechanic diagnosing a broken engine, all the way to the courtroom testing a rigorous hypothesis. You now know that research is definitely not just one boring monolithic activity. It's a massive, dynamic family of problem-solving approaches. So, I leave you with this one question. Having seen this whole map of discovery, what kind of research are you ready to tackle? Thanks so much for joining me, and I absolutely cannot wait to see what you discover next.